Good morning, my dear students. My name is Anjane Sharma, working as physics lecturer in one of the reputed institution in Hyderabad. Today, we are going to know very important concept, IB point of view and also objective point of view, that is about conservation of energy. Okay, conservation of mechanical form of energy in case of a freely falling body. Okay, our concept is about conservation of energy in case of a freely falling body. Okay, you know what is conservation of energy? Energy remains same. No, energy remains constant. Energy is neither created nor destroyed, it remains same. So what is conservation of energy? Energy, total energy remains same. Okay, so work done by a conservative force, like you see gravitational force, electrostatic force, okay, spring force. Due to these conservative forces, total work done by the system of particles is zero. So whenever total work done by the system of particles is zero, you can say energy remains same. For example, you see when you are throwing a body vertically up against gravitational force, you know, work done is minus mgh. No, because when you are throwing a body vertically up, so it is moving against gravity, no, so slowly it raises some height. So at a particular point, you know, its final velocity becomes zero and again it returns to ground only due to influence of gravitational force. Then you know work done in this case plus mgh. Therefore, what is total work done? Zero. So remember, work done by a conservative force like gravitational force, electrostatic force or spring force is zero, then we can say it follows conservation of mechanical form of energy. Okay, so you know the mechanical form of energy means sum of kinetic and potential. Okay, so mechanical form of energy means kinetic and potential. Okay, now let us consider a freely falling body. Okay, so which is allowed to fall from certain height, say h. Like this. Okay, so you are allowing a body to fall from certain height. No? So you know at point A, at point B, at point C, if total energy remains same, we can say it follows conservation of energy. Okay, so let us consider at point A. So you are leaving a body from h height. No? At a point A, total energy at point A. So you know it is allowed to fall from h meters height. No? So potential energy, you know, energy possessed by a body by virtue of configuration, position, no, is called potential. So potential energy at this point A is mgh. Okay, next about kinetic energy. You know, energy possessed by a body by virtue of direction, motion is called kinetic. So here it is at point A and about to fall. You all know initial velocity of a freely falling body is always zero now. So that is why half m0 square. No? So total energy is equal to mgh plus 0 equal to mgh. Say equation 1. Therefore, what is total energy of the body at point A? mgh. Okay, so when the body is allowed to fall, so in this way it is falling now. Say if it is at point B. Okay, so whenever it is at point B, so it will gain some velocity because it is moving towards ground now. So that's why it will pick up some velocity, it will gain some velocity and also travel certain distance, say x. Now at point B also you want to calculate the total energy. Now total energy at point B. Okay, so starting velocity is 0. Velocity at this point, for our convenience, take V1. Let V1 be the velocity. Okay, so displacement x. Okay, so acceleration for a freely falling body is always due to gravity na plus g, because it is coming towards ground. No, so V known, S known, A known. Starting velocity for a freely falling body, 0. No, so make use of relation V square minus U square equal to 2AS. No, means V1 square equal to 2gx, right? Therefore kinetic energy at this particular point, half mv square now. So 2 to cancel mgx. So kinetic energy at point B is mgx, right? So you want to know total energy. That means you should find potential also, no? So potential energy is mgh, means its position from ground. It is at a height h minus x. Why? Because it is fall from h meters height. It is already traveled h distance. That means present this body is at a height of h minus x from ground. No, so that is why mg of h minus x. No, so nothing but mgh minus mgx, right? So total energy, mechanical form of energy is sum of kinetic and potential now. So kinetic mgx plus potential mgh minus mgx na. So these two gets cancelled, you get mgh only. Take it as equation 2. Okay, so at point A total energy is mgh. At point B also it is mgh. Now we want to find at point C just before it touches the ground. Okay. So total energy at point C. Okay. So velocity at point C be V2. Okay. Let V2 be the velocity at point C. Okay. So its starting velocity is 0. Final velocity is v2. And it is traveled a distance h. No? So displacement is h. So make use of relation v square minus u square equal to 2a. Yes. Okay. So final velocity v2 square na u0, right? 2 a taken as g na displacement h. So kinetic energy at point C equal to half m v2 square. So 2 cancel, you get mg h. So kinetic energy at point C is mg h. No, just before it touches the ground. Now about potential energy. Potential energy is mg h. But with reference to ground, it is almost on the ground only. No? So that is why mg 0. Because this body is almost near to ground. No? So that is why potential taken 0. Therefore, total energy, sum of kinetic and potential na. So mg h. Say equation 3. So what do you notice? Total energy at point A, mgh. At point B, mgh. Even at point C also, you found mgh only. Means it's very clear that total energy remains same at all points. No, it is in case of a freely falling body. So very important concept. Based upon this, you will be given one long answer question. Okay, so you follow till end. I am going to solve objective model problems also based on this concept. Okay. So based on that conservation of energy, you will be given one problem. Okay. Suppose you have given a problem. There is one machine gun fires 360 bullets per minute. Each bullet mass is 5 grams, say traveling 600 meter per second. Okay, so you want to know power of the gun. So this is one machine gun, from it 360 bullets are fired per minute. Okay, so each bullet of mass 5 gram and traveling 600 meter per second. So number of bullets fired from gun you have given 360. Okay, per minute. Okay, and mass of each bullet is 5 gram. You can convert into kg now. Traveling with velocity 600 meter per second. So you want to know power of the machine gun. Okay, so power of the gun P is equal to work done by time taken. So total work done is number of bullets into half mv square, because a moving bullet possesses kinetic energy per time. So they said per minute, and number of bullets you have given 360, half, mass of each one 5 gram na, velocity 600, square so 600, okay, per minute means 60 seconds, so 60 divides 360 6 times. This will be further divided 3 times. So 20 plus 10 cancel. Okay, so 15 into 36. Now only 1 0 left. No? So 15 6 19, no? 15 3 is 45 plus 9 54 and one more 0. You can write it in kilowatt also, 5.4 kilowatt. So kilo multiple, 10 cube. No? So power of this machine gun is 5.4 kilowatt. Okay? Suppose you have given another problem. There is one machine gun. In this problem, power of the machine gun is known to you. That is 7.2 kilowatt. Okay? And this fires 240 bullets per minute. Okay? And mass of each bullet, say 10 grams. You want to know velocity, power is equal to work done by time taken. No? So number of bullets into half mv square by t na. So in this problem, power is known to us, 7.2 kilo multiple 10 power 3, right? So that is equal to, okay, number of bullets you have given 240, no? 240 half, mass of each one 10 grams, no? You must convert into kg, velocity square, let it be V only, no? By time per minute, no? So 60 seconds. So this 60 divides 240 4 times, further divided 2 times, no? So 2 divides 7.2, 3.6 times, right? 1 0 also you can cancel, right? So 2 zeros are left. Okay, so 3.6, 10 square, 10 power minus 3 v square. So this you take it down, 10 cube, further multiplied, 10 power 5 v square. Or if you take 1 0, no point cancelled, no, is v square. Therefore v becomes root 36, 6, 10 power 4 root 10 square, no? So nothing but you can say 600 meter per second is the velocity. Now suppose you have given a problem. A man of certain mass carrying luggage 50 kg, okay, climbed up a staircase of height 40 meter, say in 25 seconds. Okay, so a man of certain power climbed up a staircase of height 40 meter in 25 seconds. Suppose this man power is given 1568 watt. So man of certain power, okay, 1568 watt power climbed up a staircase of height 40 meter in 25 seconds. So the luggage mass, say 50 kg, that is given. So you want to know only mass of this man. Okay, so power is equal to rate of doing work, no? Work done by time taken. So work indicates your position, no? So potential energy, no? By time taken. So here M means total mass of man plus luggage. So in this problem, power is known to us, no? 1568, no? So that is equal to mass of man unknown, let it be M only, and luggage known. 50, no, into G 9.8, height 40 meter, no, in 25 seconds. So 5 divides 25, 5 times, 8 times. Further you simplify 1568 into 5 na, by 9.8 into 8, no, equal to m plus 50. So this 8 divides 1568 196 times. Further we cancel this and take 0 up. 98 twos 196 na. So m equal to 100 minus 50 kg. So mass of this man is 50 kg. Luggage 50. Climbed up a staircase of height 40 meter. In how many seconds? 25 seconds. So power is equal to work done by time taken. Okay? Now, in this problem, you have given how power changes with time. Okay, so you want to find change in kinetic energy between t equal to 2 seconds to t equal to 4 seconds. Power is equal to rate of doing work, no, means dw by dt. No, dw equal to p dt. So integrating on both the sides, you get total work done, which is equal to, you can take change in kinetic energy. Okay, so W is equal to, instead of power, you can write 3t square minus 2t plus 1 into dt. Now, between the limits 2 to 4. Okay, so now this integration is applied to each and every term. First term 3t square na, minus integral 2t dt between the limits 2 to 4, no, plus 1. Okay, so while integrating 3 taken out, no, t square integration, t cube by 3, limits 2 to 4, minus 2, t integration, t square by 2 na, between the limits 2 to 4, plus dt means t na integration 2, 4. Okay, so upper limit minus lower limit, upper 4 now, so 4 cube minus 2 cube, 4 square minus 2 square. Always upper limit first substituted minus lower limit. Okay, so 64 plus 4, 68 plus 2, 70, minus 16, no? So 64 plus 4, 68 plus 2, 70, 16, 8, no? 24. So I can take 46, no? Units, power units given what? Therefore, energy units, joule. Okay? So change in kinetic energy is 46 joule. A body is projected vertically up to certain height. So at a point, the ratio of potential is to kinetic is 1:4 when it is thrown with u velocity. Okay, so you have given a problem. A body is projected vertically upwards with certain velocity. At a point, ratio of potential is to kinetic is 1:4. If it is projected to same height, okay, with double the velocity, okay, with same mass, you want to know potential is to kinetic at same point. So you know in the beginning it is having kinetic energy, no? So kinetic energy half mu square, no? In the beginning. So at this point, you know, total mechanical energy is potential plus kinetic. According to problem, potential is to kinetic is 1:4. No? Therefore, kinetic equal to 4 times of potential na, means 4 mgh. Therefore, you can take 1 mgh plus 4 mgh. No? So total 5 mgh, which is equal to half mu square. So in the beginning it possesses 5 mgh energy, but now same body is thrown up with double the velocity. That means u taken as now 2u whole square. That means 4 times of half mu square na, 2u whole square. Nothing but you can take 4 times of half mu square. So instead of half mu square, you can write 5 mgh, no? So total 20 mgh. So in this case, total energy is 20 mgh. But at this point, you know, one is potential, remaining is kinetic. Means potential is to kinetic at same height is 1 mgh already taken. So total 20 na, out of that 1 taken. So 19 mgh. No? So cancel, no? 1:19. So what is ratio of potential is to kinetic at the same point? 1:19. That is if it is thrown with double the velocity. Now you have given a problem. There is one well of deep 25 meter. Okay, 600 kg of water. Okay, 600 kg of water is lifted from a well of depth 25 meter. Okay, in 1 minute and rejected into fields with 50 meter per second velocity. Okay, so you want to know power in this above task. Okay, so in this task you want to know total power required. 600 kg of water is lifted from a well of depth 25 meters in 1 minute and rejected into the fields with 50 meter per second velocity. You know, power is equal to work done by time taken. Now in this case, you know, water is lifted from a well, at the same time it is also rejected. That means it requires both potential and kinetic. No? So mass 600 kg. No? Into gravity. Acceleration due to gravity, no? 10. Height 25 meter, no? Plus mass, you have taken already common, v square by 2. No? So 50 into 50 by 2. Per minute, no? So 60 seconds. So you want to know power of the engine required to lift water and to reject. Okay, so so 1500 no into 0. So power required is 15 kilowatt. Okay. If you like this video, please subscribe, like, share and forward to your friends. So I can give you more and more updates in all competitive exams like NEET, JEE Mains, EAMCET and other competitive exams, and also for your board exam. Okay. Thank you. Thank you.